Okay, so we are looking at classifying real numbers. All numbers that can be represented on a number line are called real numbers. We touched on this just a little bit before when we talked about having a square root of a negative number. That is not a real number. We cannot have that. But we will later on in Algebra 2 come up with imaginary numbers. But we've got different classifications for those real numbers. Do not get concerned about this. I will give this to you again in the last slide, but basically I have a Venn diagram that shows the different classifications. So the most restrictive definition of a number is a natural number. So natural numbers are what we often call counting numbers. So here is our smallest circle and oval, I suppose. Going out one ring, we see whole numbers. We've taken all of our natural numbers and all we've added is a 0. Then going out one more, we've got integers. We add all of the negative numbers. And finally, we come to this outer ring of rational numbers where you see we've got fractions and decimals with repeating digits. And we'll look at all these examples in a minute. And then finally, irrational numbers, which do not fit any of these definitions. Okay, so again, natural numbers, and these you're going to want to write down in your notes. Natural numbers are the counting numbers, 1, 2, 3, etc. Whole numbers, add to the natural numbers a 0, so we start with 0 now. Integers are whole numbers and their opposites. So I've got all the negative numbers, 0, and then all the positive numbers. Sorry about that. And then rational numbers are any numbers that can be expressed in the form a divided by b, where a and b are both integers and b is not equal to 0. Remember, b in the denominator means I have a value that is undefined. So I can't have a denominator with the value of 0. So these are all examples. One thing to take note, remember, 7 is really just written as, not going to work. 7 is really the same as 7 over 1 or any other number that you have if you're trying to multiply fractions. 123 times 3/4 is really 123 over 1 times 3/4. Okay, terminating decimals are rational numbers in decimal form that have a finite number of digits. So there's an ending to this, 1.5. There's nothing after it. Of course, I can put zeros, but there's no other value. Repeating decimals, there we go, are rational numbers in decimal form that have a block of 1 or more digits that repeat continuously. So here we've got 1.3 and that 3 repeats. So this is really 1 1/3. Or 0.6, the 6 is repeating. Here we've got a number that has two numbers that are repeating, 2.14141414. Those are repeating decimals. Those are considered rational numbers. Irrational numbers, though, cannot be expressed in the form a over b. So these include square roots of whole numbers that are not perfect squares. Remember, we looked at like the square root of 12 and non-terminating decimals that do not repeat. Square root of 2, square root of 11, pi is another really good example of an irrational number. Okay, so here is that Venn diagram again. This would be a great time to pause the video and draw this down in your notes. And we are going to be doing some activities with this in class tomorrow. Good luck.